Hi, my name is Jess, and I'm here to talk with you about unlocking multilingual insights. We're going to walk through how to translate data sets using Python, LangChain, and Elastic's database capabilities. So, translating from one data set to another, it could be a really powerful tool, and it allows you to gain insights into a data set that you previously might not have been able to, allowing you to see new patterns and trends. So, LangChain can take a data set from one language to another and translate it into the language of your choice. And then after the data set has been translated, you can actually use Elastic's vector database capabilities to gain additional insights. So I'm going to walk you through in this video how to load data into a data frame using pandas. And then we're going to translate the data from one language to another using LangChain. And then we're going to load the translated data into Elasticsearch. And we're going to use Elastic's vector database capabilities to learn more about our data set. And this is actually a video of a article that I wrote a couple of months back. So really excited to share this with you today. So the first thing I'm going to want to do is I'm going to want to set my OpenAI API key. And I'm going to want to set this as an environment variable. So since I'm using a Mac, I will want to type in export OpenAI API key, and I'm going to want to set that value to be equal to my API key. This will allow me to seamlessly work with my environment variable when I'm working with my data in a Jupyter notebook. So after you have your environment variable set, now you're going to want to make sure that you have Python installed. We're going to be using a version of Python that is 3.12, but you can really use any version that's higher than 3.9. And we're going to be using Elasticsearch. So you're going to want any version of Elasticsearch that's higher than 8.0. And then from there, you're going to want to install the required packages. So you can pip install Jupyter, which will allow us to run a Jupyter notebook, pandas, which will allow us to work with our data interactively, LangChain, which will allow us to connect to AI type endpoints like the OpenAI API. From there, we can also use Nest Async IO that will give us just some extra features on the built-in Async IO package. And then from there, we're going to be using LangChain Elasticsearch that will give us just a couple of methods to help us to connect to Elasticsearch a little bit easier. From there, we'll also be using LangChain OpenAI, which will let us connect to the OpenAI endpoints tick token, which is helpful for just some data parsing and manipulation. Elasticsearch to connect to the Elasticsearch endpoints so that we could upload our data into a vector database. And then we're going to be using Datasets to connect to one of their packages. That's pretty cool. And that's actually what we're going to be using. It's a library created by Hugging Face, and we're going to be using that to actually kind of connect to a data set that's one of their sample data sets, which is kind of a fun starting point. It is a data set that has news clippings in Spanish of Spanish newspaper articles. And the data set actually has two subsets, which is Castilian and Spanish. So for the purposes of today's video, we're actually going to be using the Spanish version. And from there, we see that the data set contains an ID, a summary, and an article. And we're going to be translating the summary field and the article field into English. And then from there, we are going to be uploading that into Elastic's vector database and running some queries from there. So inside of your terminal, you will first want to log into Hugging Face using their command line tool. And this will allow you to authenticate and connect so that you can work with their data set with the Spanish language newspaper articles. And then from there, you're going to actually want to launch a Jupyter notebook. And you could do that simply by typing Jupyter notebook to have that launch. So that's the next step. And then from there, we're going to work with our Jupyter notebook. So after typing Jupyter notebook, from there, you will likely get a blank version of this. So for you, if you're starting from a new, you're going to want to click where it says new. But for the purposes of today's video, I'm going to walk you through the notebook that I created. So if you go to where it says translate and vector database, you can actually click there to launch the previously created Jupyter notebook. And I'm going to walk you through the code that I wrote. So the first thing is that I import pandas as PD. I'm going to be using pandas for lightweight data manipulation. I just like working with it when I'm working with data sets and uploading things. I like using it for data cleaning. And then from there, you're going to want to import async IO. This will be useful for creating an event loop. And then from there, we're actually going to be using LangChain's document, which will allow us to upload our data into our vector database. We're going to be using OpenAI for translation and for vector embeddings. We're going to be using Nest Async IO, which is a wrapper around Async IO that I just like working with. LangChain's text splitter for character text splitter. It's a really great just character text splitter that's useful for the chunking process. From there, we're also going to be using LangChain's Elasticsearch wrapper. And we're going to be using the Elasticsearch store, which will allow us to easily connect to Elastic's vector database capabilities. And then from here, we're going to be using LangChain OpenAI for their OpenAI embeddings, which allows us to work with our data and add embeddings to it. And then from there, we're going to be using Elasticsearch, which is the Python client for Elastic Get Pass, just so that you don't see my passwords. Functools, which is just helpful in the uploading process, and datasets to load our data set in, and particularly the load dataset method. So the first thing is we're going to want to set up Nest Async IO.apply. And then from there, we're actually going to want to load our data set in. We're only going to be using Spanish for today. As I mentioned earlier, you could use Spanish or Cotillion. I'm only going to use that. And then from there, I just like to view what my data set looks like. So I see that there is a training, there's validation, there's test I and test NI. For the purposes of today, I'm actually only going to be using the training data set. And due to preventing rate limits, we're only going to be using 25 rows. So when I pass in sample n25 or n equals 25, I'm saying, hey, I only want the first 25 rows, or I want a random sample of 25 rows rather. And that will allow me to kind of just create a subset of a kind of random sample of 25 rows on my data set. And then from there, I could kind of save that as a subset, parse the data, and take a look at that. It includes the ID, the summary, and the article. So from here, now we can actually get started with some of the fun stuff, which is translating our text. So we can create an async function that will allow us to create an event loop, and from there use OpenAI's chat completions with the GPT-4o model. And we could say to it, hey, you are a translator, please translate the following into English. And then from there, we can actually create another function that will translate the column. So we have column 1 and column 2. And then from there, we just want to make sure that we pass in translated plus to that. And so from there, we can actually create our event loop and run it until it's completed. And once it's done, you can see here that we have this ID, summary, and article that we had before. But now we get back the translated summary and the translated article, which is pretty awesome. And so from here, if I just want to take a look at the first 5 rows, I could just take a look at it as subset.head, or subset data frame.head rather. And then from here, we actually have this ES client. And this is our Elasticsearch client. So from here, we can actually pass in our host, which is our Elasticsearch URL, and our API key. And then from here, we can create a index called VS post data, and we could check to see if the index exists using the keyword argument. And from there, we can create a new index. So that will delete the existing index if one already exists with the name, and if not, it'll create a new one. And then from there, we can actually set up to start working with Elastic as a vector database. So the first thing that we're going to want to do is we're going to want to set up embeddings. And embeddings takes everything and turns it into numbers, basically. So we are going to be using the OpenAI embeddings. And the model that we're going to want to pass in is text embedding 3 large. And then from here, we're going to actually have this Elastic vector search object. And then from there, we're going to be using the Elastic store method of LangChain. And then from here, we're actually going to pass in that the index name is called VS Post Data. The Elasticsearch connection is going to be that Elasticsearch client or ES client that we created, and the embeddings are going to be that vector embedding, the OpenAI embeddings, text embedding 3 large. And then from here, we're going to translate the text. So we're going to take all of our translated text, turn it into a list. And then from there, we're going to actually use each line to kind of join the translated text. And then from there, we're going to be using chunking. So we're going to be using the character text splitter. And our chunk size is currently set to 5,000 with a overlap set to 50. And then from here, we actually can split the documents. We do get a warning here. But then from here, we can actually add the documents. And from there, we've uploaded everything into our index. And from there, we can actually start to run some queries. So from here, the first query is going to be really simple. It's going to be what happened in Spain. This is kind of like a RAG type query. And from there, we can actually do a similarity search using the query. And then we can kind of start to get back some results. And then the same, if we want to adjust the value of K to kind of start to kind of tweak that a little bit more, we can actually change that to 10 and we get back a lot more results. So this is just a very simple kind of way of kind of searching. To make this more robust in the future, you might want to consider adjusting the value of K, or you can also add things like num candidates and things like that too. So as I mentioned previously, this is just the start of what you can do to leverage Elastic's vector database capabilities. As I mentioned previously, you can adjust the num candidates field to the number of approximate nearest neighbors candidates on each shard. We also have a really great resource on the subject, and it's a blog post that kind of walks you through how to choose the best K and num candidates for KNN search. I also linked to a resource on tuning an approximate KNN search as well that can provide you with kind of next steps on making it more robust. By leveraging LangChain and Elastic's vector database capabilities, you can draw insights from a data set that may contain a language that you're not familiar with. So at the end of this article, we were able to ask questions regarding specific locations mentioned in the text and receive responses. So to dig into Elastic's vector database capability, you may also want to check out our tutorial on the subject as well, that kind of walks you through how to get started with vector search. We also have another tutorial that's pretty cool on building multilingual RAG using Elastic and Mistral. That's also a pretty cool data set. And we also have another tutorial on working with multilingual semantic search as well. So we have lots of resources. There's also tons of articles on this blog as well. And you can check out the full code in our Search Labs GitHub repository. Let us know if you build anything based on this blog or video. And we hope to see you soon. Thanks for watching today. Bye.